Hello, my geometry students. Good to see you back, or hear you back, or you hear me back, whatever. So this is an interesting kind of fun thing. We get to do some algebra right now in geometry. So last March, we all know, right, the world sort of stopped for a moment and we did not get to finish the material that we were covering in Algebra 1. So there is important stuff. You're going to need to be able to use these just like we've been solving equations all year long. Constantly happens. Well, you knew how to solve equations. Well, systems of equations, I think I threw a problem or two in somewhere along the way. We want to make sure that you've got those down. And we've also got to know how to factor and solve quadratics. So we're going to take a little pause and we're going to do some geometry algebra lessons. So we are just going to do, if you looked at the notes packet that I put out there, it's a set of algebra notes. And they're actually the algebra sections. So let's start with, this should be a review. So algebra review is solving systems and multiplying polynomials. So when you solve a system of equations, look at the examples on this page. It's two equations with two variables. We usually can't solve an equation if it's got an x and a y in it, right? That's a problem. So when we're solving a system, we're looking for an ordered pair that satisfies both equations. Satisfies means that it has a true statement. So you need one ordered pair. You can put the x value in, the y value in both equations, and they both come out true. It sounds difficult because you'd have to do a lot of guessing and checking if you didn't have another method to do. Well, there's three ways to do this. You can graph them, and you can figure out where those two lines will intersect. If it's an x and a y equation, right, we've got an x-axis and a y-axis, so they'd be lines. So you just find the point of intersection. We're not going to do that right now. We can graph some other time. We're going to do this algebraically. So hopefully you remember substitution. So you substitute one variable in, or one expression in for a variable, and then you can solve it. And elimination. We can multiply equations, put them in standard form, and that way you can eliminate one variable and solve for it. Please note your answer is an ordered pair. So when you give your answer after you solve a system, you've got to make sure that you have an ordered pair. So substitution is usually easiest when you've got an y equals everything else or an x equals equation. Because then I can say, oh, well, whatever this is equal to, I can plug that into the other equation for y. Or whatever x is equal to, I can put that into the other equation for x. Elimination is typically easiest when you've got equations in standard form. Everybody remembers standard form, right? Standard form is when you've got something x plus something y equals your constant c. And everything's nice and neat and lined up, and you may need to multiply. Change colors there. You may need to multiply an equation. So let's do an example of both. I am hoping, my fingers are crossed right now, you cannot see them, but my fingers are crossed that you remember how to do these and it all kind of floods back in. So let's do an equation of, or an example of substitution and an example of elimination. So on this sheet it says solve each system, use any method. It doesn't matter to me how you do it as long as you get an XY ordered pair answer. So in problem number 1, notice I've got a 2x minus y equals 3. All right. Second equation, it's y equals x plus 4. Well, that's super nice, right? It's telling us what y equals. I like that. It's ready to go. So I can take this x plus 4. It says that's what y equals, so I can put that into the equation wherever I see a y. This is a nice tricky one to start off with because it says 2x minus whatever we've got for y equals 3. So I'm going to put that x plus 4 in there. So instead of writing y, I'm going to write x plus 4. This one I had to be careful with because it's got that minus y. You have to distribute the y to both of those terms now. So that one was really sneaky. Watch for those. If it's a plus, we don't really have to do much else. We just put it in there. So if I distribute that negative, I have 2x minus 4 equals 3. I've got a pair of like terms to combine. 2x minus x is x. 1x, right? Minus 4 equals 3. And then I'm going to do a quick add 4 to both sides. X equals 7. But I am not done because, remember, I need an ordered pair. So it's an ordered pair that works in both equations. You can take that x equals 7. You can go back to up to either equation. It doesn't matter which one you go to. As long as your x is right and you solved it right, you'll get the same answer because this ordered pair works in both equations. So in this case, I'm going to go to this bottom equation. It says that y equals x plus 4. Well, I'm going to put that 7 in place of the x, right? Because we found out that x equals 7. So, whoa, I wrote a x instead of a 4. There we go. So this is pretty simple. It says that y equals the value of x, 7 plus 4, so y equals 11. So my final answer, ordered pair, x first, then y, 7, 11. I've got myself an answer, and I feel like a Slurpee at the same time. That's elimination, or that's substitution. I think substitution is easiest when you have already a y equals equation or an x equals equation. If you didn't, you could make it happen. When I look at number 2, the top equation, 2x plus y equals negative 4, that y would be pretty easy to get by itself, subtract 2x from both sides, and then I could substitute that in for the y. If you don't like that, I notice both of these guys are in standard form. So I'm going to look at both of their coefficients. So the two coefficients of x are 5 and 2. The two coefficients of y are 1 and 3. I need to think to myself, which one would be easier to make both of them the same term, the same coefficient? So 5 and 2 we know would be 10, right? So I could multiply the top equation by 5 to make it a 10. I could multiply the bottom equation by 2 to make it a 10. But I think the y's are even easier because if I want to make both of these guys a 3, the only thing I need to do is multiply the top equation by 3. And then there's a little sneaky secret. We want them to be the opposite signs. Since they're both positive, if I wanted to make this a negative 3y for the top equation, I'm just going to multiply by the negative or the opposite sign. So I'm going to distribute that. Make sure you distribute to all 3 parts. So when I distribute that, I get a negative 6x. Negative 3 times y is negative 3y. Bring the equals down. Negative 3 times negative 4 is 12. I do not need to change my other equation at all because it's already got a 3 for its coefficient of y. Now comes the really nice sneaky part. Add straight up and down. What do you notice is going to happen with our y's then? Right? Negative 3y plus 3y, those guys cancel out or they get eliminated. That's why this is called elimination. We eliminate a variable. Sometimes you have to do a teeny bit of work by multiplying one or both of the equations. You want the same coefficient for one of your variables, it doesn't matter which one, with an opposite sign. So my 3y's, positive and negative, cancel out. Negative 6x plus 5x is negative 1x. Bring my equal sign down, equals 6. Divide both sides by negative 1, and I get x equals negative 6. That's a negative 1. But I'm not done, right? Because my answer has to be an ordered pair. So I'm going to go back to either equation, and I'm going to substitute in the negative 6 for one of the x's. I'm going to pick the top equation because the number seems smaller. You can use either equation. So 2 times negative 6 plus y equals negative 4. Let's see, so negative 12 plus y equals negative 4. And then I'm going to add 12 to both sides. So y equals 8 according to my calculations. Hopefully I'm right. So my ordered pair answer, x first, then y, I got a -6 and then an 8. Final answer for that problem. You can use whichever method seems easiest to you. It doesn't matter to me. I do want to give you a quick heads up here. On number 5, I made a typo. On number 5, make that top equation be equal to -3. -3, sorry about that. So number 5, your equation is 2x plus 5y equals -3. You're going to get a really ugly fraction or decimal answer if you don't fix that one. So hopefully you watched this and you heard me say that. -3. All right, if you flip the paper over, I'm thinking you remember this for sure. I put a couple notes here. They're not on your sheet. I know if you want to jot this down somewhere, when you are multiplying polynomials, you multiply your numbers. So just like always, 5 times 2 is 10. You have to watch your exponents. This requires a little bit of throwback to Algebra 1. What happens to your exponents? You add the exponents on your variables. And combine like terms if possible. So for number 7, if I'm going to distribute, notice it's just a distributive property problem. We know how to do this. I'm going to distribute that x to both of those terms. So x times 5x is 5x to the second power because it's a 1 and a 1 on my exponents. And then I'm going to do x times x squared. So that's going to be a positive x to the third power. So just watch your exponents, multiply your numbers. If I scooch down to, say, number 13, notice I've got a distribute, but then I've got a -5x sitting out at the end. The distributive property ends at the parentheses. So x times 3x would be 3x to the second power. X times a -4 would be a -4x. I still have that -5x. You just bring that guy down. Like terms, I can combine my x's, not my x squares. They have to be identical variable and exponent. So that's going to end up being a 3x squared, didn't change. A -4x minus 5x is going to be -9x for my final answer. And last but not least, is this all coming back to you? You remember how to do these? Find each product. A lot of teachers call it FOIL. A lot of teachers call it distributive property, kind of extended. I usually call it the line method, which is kind of a dumb name. But if you're a visual person, the line method tells you, you take each term in your first parenthesis. So I'm going to start with this x, and I'm going to multiply it by everything in the second parenthesis. So I'm going to draw a line from this guy. So x times x is x squared. A line from here, x times 3 is positive 3x. And then I go to my second term inside, it's a positive 2. And I multiply by what's in the other parentheses. So positive 2 times x is plus 2x. A positive 2 times 3 is plus 6. And then I'm going to combine my like terms. I've got a 3x and a 2x are the only like terms I've got. So my final answer is going to be x squared plus 5x plus 6. So I've got a trinomial for an answer. So you're going to do that all the time. You're going to do the line method. FOIL stands for first. So the first term in each parenthesis. The O stands for outsides. The I stands for the insides. And L stands for last. So FOIL is really my line method. If you get to something, do I have any? I don't have any 3 terms. So I thought I had 3 terms, like a binomial times a trinomial. The line method helps if you've got those. So that is algebra review. I know that you did these things last year. I have talked to your teachers, people, so I know that you knew this at one point. I hope it just was a little foggy and it's all come back to you. If you've got questions, please let me know. The next thing that we do when we start taking notes and watching YouTube videos or videos off of Google Classroom is going to be brand new stuff. So stick with me, work at this. Hopefully you're excited to do some algebra and take a little geometry break here midway. And we've got this. Keep working away. Thanks for being awesome. See you next time.